All right. I think the echo has disappeared. So sorry about that, everyone. And welcome, NOVA fans, to this virtual field trip. I'm very excited to be here with you today. And thank you so much to all of our students who are joining us from classrooms across the country. Welcome back to school. My name is Tara Ramsey, and I'm the Outreach Projects Manager with NOVA Education, and I'm really excited to host this virtual field trip on the neuroscience of creativity. And I think it's really, really fitting that our first virtual field trip of the school year is on neuroscience, as we're getting kind of back into using our brains. So back in May, NOVA premiered a two-part documentary series called Your Brain, which covered topics in neuroscience such as perception, consciousness, creativity, and more. The first episode was called Perception Deception, and it asked questions like, what is reality? And it turns out reality is perhaps not as concrete as you might assume. The second episode was called Who's in Control? And that film asks, like, what are the factors that manipulate our behavior? Are you controlling your actions, or is your brain controlling you? Which brings us to today's topic, consciousness and creativity. You know that feeling of being hit with a great idea? The question today is, where does that feeling come from? Where does that moment of intuition arrive from? What is really going on in our brains when this happens? And is it possible to train our brains to have more of those aha moments? So today we are going to dive into what that process looks like. And to lead us on this journey into the depths of the human psyche is none other than the host of NOVA's Your Brain series, Dr. Heather Berlin. Dr. Berlin is a neuroscientist, a clinical psychologist, an associate clinical professor of psychiatry and neuroscience at the Icahn School of Medicine at Mount Sinai in New York. She explores the neural basis of impulsive and compulsive psychiatric and neurological disorders with the aim of developing novel treatments. And she's also interested in the brain basis of consciousness, dynamic unconscious processes, and creativity. Hi, Heather, welcome, and thank you so much for joining us today.
Hello, thanks for having me. Thanks for the introduction. I'm really excited to be here.
Of course, we're super excited to have you. Just a quick reminder before we jump into the presentation, if you have any questions for Dr. Berlin, please drop them in the Q&A section of the Zoom or in the comment section of the Facebook or YouTube, and we will try and get to those at the end of the session. And today we'll also be hearing from several students across the country who will be asking questions live during the Q&A. So please stay tuned for that. And without any further ado, Heather, I'll let you take it away from here.
Thanks so much. It's really exciting. I'm so glad to see there's people from all over the country, all over the world. So I'm just going to get right to it. I'm going to take a second to share my screen and get those slides going. So hold on one second. Here we go. All right, you can see that? Okay, so I'm going to talk a little bit about the neuroscience of creativity, but before that, I think we really also need to understand just a little bit about the brain and how it works. And I think the brain is the most fascinating object in the known universe. It's this 3-pound piece of matter that's organized in such a way that we can actually know ourselves. It's our greatest asset. And I think the more we can understand about how the brain works, the more easily we can learn how to hack into our own brains and make them work for you to achieve your greatest potential. I became fascinated with the brain as a little girl. I had a fear of dying. I realized I was going to die one day, and I thought, well, even if I don't have a brain, can I still have my internal world? Can I still have my inner thoughts? I asked my dad, where do my thoughts come from? He said, they come from your brain. I said, great, how? And how can I keep them when I die? And he didn't really have an answer for me, but that became my quest to try to understand how this intricately organized 3-pound piece of matter can create all of our thoughts, our feelings, our emotions. And it's quite a complex piece of matter. You know, it's made up of these individual units or neurons. We have about 86 to 100 billion neurons in the human brain. Each of those has about 1,000 to 10,000 synapses or connections. So there's about 100 trillion connections in the human brain, which is more connections in the brain than there are stars in the Milky Way. It's quite a complex piece of matter. And you can think of it like an information processing machine, but it's a myth that we only use 10% of our brain. We actually use all of our brain all the time. None of it is redundant, but we're only conscious of a little bit of what's happening in the brain. And most of the processing is happening outside of awareness. And it's affecting the decisions we make and the behaviors that we do. And I'm really interested in trying to delve into the brain and sort of unlock and understand these unconscious processes so that we can better understand ourselves, because we often tell ourselves a story about why we did things, which is not always the real story. We come up with a sort of post hoc explanation, but we can tell in the lab with experiments, we can kind of give people subliminal information and manipulate them in certain ways so they behave in certain ways, so they decide certain things without really understanding the reasons why. So there's a whole slew of studies like this, some of which are, for example, they'll either show somebody, a bad boy throwing a cake or a good boy presenting a cake. And then, but they'll do that subliminally. They'll present it so quickly a person doesn't consciously perceive or say that they saw anything. Then they present this neutral image of a boy and they just say, tell me some character traits about him. And sure enough, the people who subliminally saw the bad boy were more likely to describe him with negative traits than those who subliminally saw the good boy. And this isn't just in the visual domain. We see this in olfaction as well. They gave people an experiment. At the end of it, they had sort of cookies as a reward. And then they either had no scent in the room or a faint sort of lemon cleaner scent. And the people in the lemon cleaner scented room were significantly more likely to clean up their crumbs of their cookies. So all these subtle cues around us are affecting our behavior. If you do a competitive task with two people and one person is in view of a briefcase and the other is in view of a backpack, the person who's in view of the briefcase will behave more competitively. So again, we're picking up these cues in our environment and they're affecting how we then go on to behave. And there's subliminal messages, just a couple I'm throwing out there where, I don't know if any of you can see the little hidden message here, but this is meant to have an impact on people's behavior. And this was caught in an ad for KFC. I don't know if you see right here, there's a dollar bill there. So I don't know, maybe the implication is if you eat this, you'll make money. Toblerone chocolate, which is one of my favorites. It's created in a place in Switzerland called Bern. The city is Bern, which means bear. And I don't know if you can see this, but they actually hid a little bear in their logo and the words burn. And just another example, FedEx, I don't know if you see it or not, but if you look at the negative space here, you see a little arrow pointing, right? Now, once you see it, you can't unsee it, right? Something changed in your brain. Now, whenever you see that logo, you might always see that arrow. Whereas before it was there all the time, your brain was processing it, but maybe at the unconscious level and you weren't perceiving it. And that's what we're starting to tear apart is when things are right there in front of your face, the physical stimuli is hitting your retinas, hitting the visual cortex of your brain, but you don't consciously perceive it. And then suddenly you do. What changed in your brain? It was still there, but when you saw it and when you didn't, and we're trying to track those neural correlates of consciousness. It's also important to remember that what we perceive in the world does not necessarily correlate with reality. So, for example, if you look at these squares here, A and B, they look like they're different shades of gray, but this is just an illusion. They're actually exactly the same shade of gray. If you draw a line between them, you can see that. And that's because the brain is using heuristics and making approximations, and it's building a model in its head based on these cues. So here it says, oh, B is surrounded by dark squares and there's a shadow there. So I'm going to lighten it up. A is surrounded by light squares. I'm going to darken it up. And it's just making these calculations, but it's not necessarily true to physical reality. And we all know what happened with this dress, right? This was an internet sensation where people saw the image of this middle dress, and some people perceived it, they lightened it up and saw it as white and gold, and others as blue and black. It was really blue and black, so I was right, of course. But anyway, We all perceive the world in a different way, and our brain is making these slightly different calculations all the time. So we can look at this in the lab. We can give people these like bistable images. So for example, if I primed you with words like youthful, vigorous, you might see this young girl looking away. That's her nose and her eyelash and her chin and her ear. But if I said, elderly, wise, you might see the old woman looking down. That's her chin and her mouth and her nose and her eye. The interesting thing here is the physical stimuli is exactly the same, but you perceive it in different ways, and you can never see them both at the same time. So your perception is flipping, even though the stimulus is staying constant. And again, that's how we track the neural correlates of consciousness. What is happening in your brain when you see the old woman, say, versus when you don't? And what we find is that what seems to correlate with what you're perceiving at any given moment are that these coalitions of neurons, these groups of neurons, start firing together. You can think of it like, voting in a parliament. A bunch of people vote together. And then that's what comes into consciousness. It stays there for a second or two. If you attend to it, it stays longer until it dies down and the next coalition of neurons comes into power. And that's kind of the ebb and flow of our conscious perception. It's kind of like a Twitter feed, which is actually what this is. But if you think of each neuron firing as like a tweet, and when enough people tweet about something, it starts to trend in our sort of global consciousness. And that's kind of what's happening in the brain. But it's not all coming together in one area. It's sort of, these coalitions are occurring across these distributed neural networks across the brain. This is just a neural network in a bird brain. So you can imagine how complex it is in the human brain. And what brings these neurons together, it's not that they're all firing at the same time in sync. That would be like an epileptic seizure. But they're firing sort of in coordination. You can think of it like a wave in a crowd, or all the different instruments playing in an orchestra. When they're first warming up, they're out of sync. But when they're playing a melody, they're all playing together in sync, but they're not all playing the same note. But that's kind of what happens in the brain. You get this coordination of neurons firing that brings things into consciousness. And the other thing we know about consciousness, and then I'm going to delve a little deeper into the unconscious, but is that, for example, here, occasionally you'll see a face breakthrough or a house, right? You'll see that consciously. But even when you're not seeing it, they are showing faces and houses, but it's sort of being processed outside of awareness, subliminally. And what studies find is that when things are being processed visually outside of awareness, you get activation in the back of the brain. So this is a side view of the brain in the primary visual cortex. So some of the brain is processing that information. You're just not consciously aware of it, but it can go on to affect your behavior. But when things come into consciousness, what changes is that the firing starts to occur in the prefrontal cortex, and you get these feedback loops to the back of the brain. And then when you have that kind of level of communication in the brain, that's what brings something into consciousness. And we call it fame in the brain. When something sort of catches on in the brain, then it comes into consciousness. And so this is one theory of consciousness. And another popular theory is something called the integrated information theory of consciousness. But what that really says is that any system, that basically consciousness is a property of the universe. And any system that has a high degree of like sort of differentiated, coordinated, integrated information consciousness will emerge from that. And the brain just happens to be one of those systems that's very integrated in terms of the information processing. And so consciousness emerges. But this is a sort of panpsychic view, meaning that it could be in any system. It could be in a non-biological system, and that you can create consciousness, in silicon, let's say, if you have the right amount of processing of information. The final thing I want to say, just this sort of general overview of the brain, is you can think of these two basic systems in the brain. You have these subcortical, under the cortex, subcortical structures in the brain. Some call it your reptilian brain. It's the limbic system. It's involved in sort of immediate pleasure seeking or avoidance of pain. And it's involved in our immediate desires, risk taking, emotions. You can think of it like the Keith Richards of your brain. Then you have the prefrontal cortex, which is kind of the executor of the brain, sort of the president like Biden. It's involved in planning ahead and decision-making and executing and having good judgment. So you're having these two competing systems, the drive for immediate pleasure and gratification or avoidance of pain. And then this higher order system that's saying, wait a second, let's weigh everything. Okay, I want that piece of chocolate cake right now, but maybe I want to fit into that dress or whatever it may be, and I don't want to have that right now. And so you have these two competing things, and eventually they work together, and one of them wins out, and you have an adaptive behavior. But The problems happen if there is damage to the prefrontal cortex, or the brake system of the brain, and you can't control those basic impulses. Either there's damage there or there's underactivation, which we see in certain psychiatric illnesses. And then people are acting out on their basic desires. So this is one study that they showed people neutral scenes and then aggressive scenes. And just simply viewing a scene with aggression actually decreased activation in the prefrontal cortex in the brake system. So it's kind of like when the brake is broken, the accelerator takes over. And it's interesting with ADHD, which is people who are hyperactive and have difficulty paying attention. It seems counterintuitive. You give them a stimulant, but what you're doing is you're actually stimulating the prefrontal cortex. You're stimulating the brake system so they can have more control over their behavior. And this is the case of Phineas Gage. He was one of the foundations of this idea that the prefrontal cortex is involved in impulse control, emotional regulation, and personality. He was working on the railroad in the 1800s. There was a spark of this dynamite powder, and this big metal rod went right through his prefrontal cortex, and he lived, and everything remains intact, his ability to speak and his intellect. But the thing that changed was his personality, and he suddenly became impulsive. He would say things to people that were inappropriate. He was socially inappropriate. And that's the foundation, that this part of the brain is involved in emotional regulation, behavioral regulation, impulse control. And so you can think of it like a spectrum, and the prefrontal cortex is underactivated. You get problems with impulsivity and, ADHD and things like pathological gambling. But if it's too active on overdrive in the other direction, that's not good either. Then you get things like rumination and anxiety and obsessive compulsive disorder. So, it's not good if it's overactive or underactive. You want to try to find this balance in between. So I'm going to give you just an example so you can feel what it feels like to have cognitive control. And this is an interesting example. It's called the Stroop test. And what I'd like you to do, I think Tara's going to be my test subject, but if you can all do this with us out loud, is I'm going to flash a word on the screen, and I just want you to, as quickly as you can, name the color of the ink. Okay? So here we go. Ready?
Blue, brown, black, red, orange, purple, pink, green, orange, black, purple, pink, blue, green, red, brown. Woo.
You see how it gets harder in the second column because there's a problem. Your instinct wants to read the word, and you have to kind of suppress that to read the color of the ink. But what's that feeling of suppressing that basic instinct is that prefrontal cortex in action. And when it's broken, when it's not working right, you have difficulty suppressing those basic instincts. And we find, though, the prefrontal cortex is often the last to know about things. And we're making decisions all the time just based on that basic instinct. This was a study that just showed that when people had they either were shown a pound or a penny is worth less than a pound. This was done in the UK. And they either were shown it subliminally, that's outside of awareness, or superliminally, consciously. And they were just told to squeeze a grip. And the harder they squeezed, the more of the money they could win. And what they found is that they squeezed harder for the pound because they were more motivated than the penny. But they were told to squeeze even if they didn't see anything. And what they found is that they squeezed harder for the subliminally presented pound than the penny. And they found when they did neuroimaging, looking at brain activation in real time, that parts of that subcortical areas involved in reward were active, even to the subliminal money. And they were making decisions until the prefrontal cortex was last to know. And the point is that we can be motivated subliminally by things without even being aware of what we're being motivated by. And so a lot of the time we're making these decisions using these unconscious processes. And one study showed that actually we make better decisions about complex things when we allow our unconscious to make those decisions. So they gave people simple decisions like what shampoo to buy, and more complex ones like, do you want to, take this vacation, take this job, get this room. And there's so many variables that actually consciousness is limited. It has a limited capacity, but the unconscious is basically limitless. So if you take in all the information and then don't think about it and allow the unconscious to do its work, it can actually do a better job. They measured post-decisional satisfaction. How satisfied are you with your decisions? And they found when they left it to the unconscious processes, when it came to a big decision, people were more satisfied with their decisions versus simple choices where they were more satisfied when they left it to consciousness, because they could have some very basic limited variables, like I don't want to go over this price point, or I want to have it in this color. But when the variables start to expand, should I marry this person? Should I take this job? It's better to actually take in the information and then sleep on it, lie on it, and let the unconscious do its work. And we find that most of our decisions are made with these subcortical areas, these evolutionarily older parts of our brain that are involved in emotion. They're really informing our decisions. And so, but do we have control? Yes, at some level, we can then turn on our prefrontal cortex and say, hey, I want to not maybe engage in that dangerous behavior, even though it looks like fun. We have something, what we call willpower, but studies also show that we can deplete our willpower. It takes energy to sort of activate the prefrontal cortex and suppress those urges. And the more you inhibit your behavior over time, it becomes harder and harder. If you're sleep deprived, if you're hungry, it becomes harder to control your impulses. And one interesting study found that judges who are making parole decisions, so basically it's easier to just remain status quo, have the prisoner stay in jail. It's harder to overcome that and say, oh, I'm going to let him out on parole. And they found that after their last meal, they would let 65% of people go out on parole. And then that number gradually dropped down to just about zero when it was just before their next break. Then they ate again, and then that number went up to 65. So even, judges are making decisions thinking they're being very impartial and rational, but they're still being affected by these unconscious processes. So that leaves us with the question of how much control do we really have? Studies show that, we really don't have technically free will, in that if everything was exactly the same in your brain and your environment, you could have done otherwise. There are many studies that show this. This is just one of the classic ones where they had a little ball going around this clock, and they told a person to just remember where that ball was when you had the intention to press a button with your finger, and they measured brain activation. And what they found is that this is the action when they actually did it. This W is when they had the intention to move their finger. But as you can see, up to 350 milliseconds before they even were aware of their intention to move, there was a buildup of brain activation. This idea that they call it the readiness potential, that the brain is gearing up to make a move, and only when it hits a certain point do you get the feeling, oh, I consciously decided that. People said, well, what about free won't? Do we have the power to veto our action once it's about to go into motion? And even the thought to stop a behavior once it's in motion has these sort of unconscious activation that's building up to even the decision to inhibit. So we can't get out of this cycle. But so what does that mean? So we don't have free will in the classic kind of philosophical sense, in that if everything in the brain was exactly the same, we could have done otherwise. That would mean there's a ghost in the machine. But we do have the capacity to have self-control. And self-control is we basically measure it with how fully developed and healthy a person's prefrontal cortex is, how their brake system is working. And that's why we hold a 5-year-old less responsible for their actions than, let's say, a 25-year-old, because the prefrontal cortex isn't really fully developed until about the age of 25. So this has interesting consequences. Young people don't have as much impulse control, but at the same time, they're also more creative in many ways, because all those constraining behaviors and thoughts that might seem outside the norm allows for creativity. But what's really interesting is that there was this classic marshmallow test they gave to kids between the ages of 3 and 6, a whole array of tests, including this one test, the marshmallow test, where they said, you can have 1 marshmallow now, or you can wait and have 2 later. And they would leave the 1 marshmallow in the room, walk out of the room, and see what happens. And what they found, and they followed these people throughout life. And the thing that correlated the best with future life success was whether they could pass this marshmallow test, whether they could wait and withhold taking the 1 marshmallow for 2. And if you think about it, that scales out to everything. Can you stay home from going to the party to study instead? When you can sacrifice certain things for these long-term future consequences, that scales out at some point to life success. It's really a measure of prefrontal cortex function. So the question becomes, it's so important to have this impulse control and it's associated with all this future life success. How do we gain more of it? And there are ways to do that. There are ways that we can turn on our prefrontal cortex and, we can stop and think before we just act impulsively. We can practice mindfulness, remove temptations from our environment. There's a whole array of things we can do to try to increase the prefrontal cortex functioning. But at the same time, as I said, too much control isn't good. So at some point, letting go also has health benefits. You don't want to be out of control all the time, but if you can sort of let go in a controlled way, it can be very therapeutic. It can relieve anxiety, rumination, depression. So turning off the prefrontal cortex completely is associated with impulsivity. But when you can turn it down temporarily, or say when you're a kid, when it's not fully developed yet, it's also correlated with creativity and spontaneity and making novel associations between ideas. So you have all this information in your brain, and your prefrontal cortex is normally like the executor, and it's constraining it and saying, you have to think in a socially appropriate way and behave in a socially appropriate way. But sometimes when you just take off those constraints, these novel and new associations occur, and that's where creativity comes from. And we can see in some studies with neuroimaging looking at brain activation, basically looking at blood flow to different parts of the brain as a proxy measure of brain activation, you can see what happens when people are being spontaneously creative. In this case, they had people doing freestyle rap. So they had one condition where they had rappers doing a memorized rap, and another condition where they did freestyle rap. And when you compare those two conditions, you find that actually during the freestyle, the sort of spontaneous improvisation model, they have decreased activation, this area in blue, in a part of the prefrontal cortex called the dorsolateral prefrontal cortex. That part of the brain has to do with like your inner critic, conforming your behavior. So, controlling your behavior so it conforms to social norms. And that's turned down. And then you have this medial prefrontal cortex that's active, this sort of the internal generation of ideas. So what you have here is this internal generation of ideas that's sort of unfiltered. And the second you become too self-aware, or your inner critic is turned on, then you turn on that dorsolateral prefrontal cortex, and then you're out of that flow state. Because people talk about this flow state where they lose their sense of self and time and place. It's associated with very positive emotions. People strive to get there, and you can get there in different ways, but we see this similar pattern across different mediums. So for example, jazz improvisers, you see the same pattern of activation when they were in the brain, the scanner, an fMRI, it's called, and they were playing an improv piece compared to a memorized piece. During improv, you see the decreased dorsolateral prefrontal cortex activation in blue, the increased medial prefrontal cortex activation. So the filter has come off, they're not self-aware, and they are in these kinds of flow states where the brain is just sort of doing its thing, unconstrained. And that's where creativity can take place. So Eminem had it right when he said you have to lose yourself in the music. The moment you own it, you better never let it go. That's my rap for the day. But there's something to that, letting go. And again, in a controlled way, you don't want to be let go all the time, but in these ways where you can get into these flow states. And people, again, in these states, it's associated with a sort of lack of focus, but very positive emotions. And one question is, can we get to these brain states through all different art forms, like, painting improv, or theater improv, comedy improv, dance improv. And it doesn't have to be during these art crafts. It could be during, some people do physical activity like rock climbing or playing tennis, but where you lose your sense of time and self and place, the brain, you have to train it first consciously, right? So a jazz musician isn't just playing random notes. They first have to consciously learn all the notes and the chord structures and everything and all the rules. And then they can let go and improvise and break the rules. But first you have to kind of consciously take in that information. You're not just playing random notes, right? There's still a structure to it, but it's all sort of instantiated in your unconscious. And again, it's not just in these creative endeavors, we see that pattern of brain activation. We can see it with meditation, in certain states of daydreaming, hypnosis, and sleep, REM sleep. Again, where your prefrontal cortex activation is turned down, kind of anything goes. Dreams are strange and they're illogical and they don't make sense, but they can be very creative states during REM sleep. And actually, there's a study that shows that sleep can inspire creativity and insight. So this was a study that was done in Germany, where a group of people were taught a relatively complex math problem, but it had a very simple solution, an abstract rule that would allow them to come to a very quick solution. So a few of the subjects figured it out spontaneously at the first time, but many did not. So then each participant was retested 8 hours later, and some of them were allowed to sleep and others had to stay awake. And only 23% of the group that stayed awake came up with the faster solution. But the people who were allowed to sleep, 60% of them came up with that shortcut. So sleep allows the brain to sort of process information, allows the unconscious to work on it. As when we sleep is an active process. We're replaying things in our brain, we're extracting meaning, and it consolidates memories, and it allows for these insights. So another tip is that if you find yourself stuck on something, or you can't come up with a new idea, or there's a problem you can't solve, try to think of it before you fall asleep. And one study found that people who did this, half of them dreamed about the problem, and for 70% of them, their dream included a novel solution to the problem. The other thing is, that's really another quick tip, is take naps. Naps can actually, one study found that if you took a 60 to 90 minute midday nap, I don't know if that's possible for anybody, it had more benefits for creativity than drinking coffee. Salvatore Dali and Einstein had this thing where they would take these micro sleeps. It was called something like the key and the spoon method, where they would sit with a key or a spoon in their hand and let themselves drift off. And as soon as they fell asleep and the key dropped, it would wake them up. But they would have this micro sleep, and they would enter what we call like a hypnagogic hallucinatory state, which is the transition between sleep and wakefulness. And a lot of creative ideas can come in those states. And these are just some of the amazingly, creative people or interesting people or successful people who would take naps. They were known for taking naps, and this really helped with their productivity and their creativity. And so another another kind of way to get to this brain state and to be more creative is through meditation. We find that certain types of meditation decrease prefrontal cortex activation. And the other thing that we see a similar pattern of activation is what we're using now, called psilocybin, which is the ingredient in magic mushrooms. We're using that for psychotherapy now, but we find that psychoactive drug actually also decreases parts of the prefrontal cortex as well, and gets people into these flow states. And if you just look very quickly at this is a schematic of connections in the brain. So the longer lines are further away connections in the brain, the shorter lines are closer together, the thicker they are, the stronger the connection. So this is a sort of a cortical map of the pathways in our brain, and when you're functioning on a placebo. And this is what it looks like on psilocybin. So as you can see, there's this hyperconnectivity. The pathways are all over the place. If you were in this state all the time, it would be really maladaptive. It would be like being like schizophrenic, right? Just completely disorganized. But if you sometimes get into this state where you lift the constraints, and it does not have to be done through drugs, it could be done through creativity and all these other methods that I've talked about, meditation. But when you lift that constraint, it just allows for this free information to flow across the brain, allowing for more novel association between ideas and creativity. So we all have this capacity. It's within all of us. We're malleable. The brain is kind of like a piece of clay. It's very malleable when you're young, and it sort of hardens across our lifespan, but it's always amenable to change. So they're like these pieces of clay sculpted throughout our lives. Our genes provide like a raw material, but we're actually born with billions of neurons, with trillions of connections, more than we need. And as we mature, it's actually a process where it's a pruning process, where they get rid of connections that we don't need, and it becomes more refined and defined. But we always have the capacity to change. That's why therapy works, because people can change to an extent, and we can all become more creative if we learn how to sort of find that childlike part of ourselves, let go, kind of find ways to lose yourself, not be so self-conscious, and allow that free flow of information. But you have to do the hard work. You have to learn the skill you're trying to learn. If it's tennis, for example, you have to consciously learn how to hit the ball. But once you've picked up all the skills, then you will perform the best when you let go and don't think about it. Let the unconscious take over and do its thing. So the more I learn, the more I realize just how little we actually understand about the neural basis of consciousness and unconscious processes. We still don't know exactly why certain things come up into consciousness from the unconscious, or why things get suppressed or repressed. We don't really fully understand how therapy works or why it works, and how it changes the brain. But we're learning all of these things. And we also are trying to understand, get an overarching theory of consciousness, because we need it to know whether, for example, does a bee have it? Does a fetus have it? Does an AI program have it? Does the internet have it? Right? And that matters to us, whether our robot is conscious, because if you kick a refrigerator, it's okay, it doesn't matter. But if you kick the refrigerator and it can feel pain, it has a conscious perception. You don't need language for consciousness. You don't need a sense of self. It's just pure sensation. Then that matters. That has ethical implications. But what we can do with the knowledge we have so far is that we can try to understand our own unconscious motivations, our desires, our fears. We can look inward and sort of know thyself, right? Try to reflect and live more in line with our underlying desires and achieve more of our long-term goals, and ultimately achieve wisdom, which I think is a combination of having experience, knowledge, self-awareness, and good judgment. So, I started out studying consciousness in order for a way to try to find a way to kind of cheat death. I haven't found that yet, but what I got instead was this amazing feeling of awe that this 3-pound piece of matter can give us the ability to ask these questions and attempt to answer them. And I want to leave you with this picture because this was the first picture taken of the Earth from the moon in 1968. And this had a profound effect on millions of people. It started the environmental movement as well, because it fundamentally changed our perspective. Like Earth is this kind of precious, fragile little dot in the middle of nothingness. And we need to protect it. We need to not care so much about all these arguing between us, because we're all just living on this tiny pale blue dot. I'm hoping that this perspective of your brain, understanding it and how it works, will change your perspective about yourself. Our brain defines who we are. It's the source of all of our triumphs and also it can be our ruin and downfall. So by learning to know yourself and the sources of your impulses, and by choosing when and where to set them free or when to rein them in, you can become the best version of yourself and make your brain work for you. So we can all learn to master the fine art of losing control. And I will leave it there, and I'm happy to take any questions, and I open it up to Tara now. I'm going to stop my screen share.
Fantastic. Thank you so much, Heather. That was absolutely fascinating. We do have a lot of questions coming in, and we also have some students standing by in some classrooms who want to ask some questions live. So I'll get straight to those questions from the Zoom first. Here we go. Let's see. Teresa from Zoom says, can the brain improve creativity in older ages over 60 or 80? I think you touched on this briefly, that we can, our brains are malleable, which I love because we're always trying to improve. But is it possible over 60 or 80? And are there parts of the brain that become stronger as one ages?
It's really interesting. Everyone thinks of aging as like a sort of downward process, but we do lose things, but we gain other things. And there's something called fluid intelligence, which is being able to process things in real time as they come to you. And then there's something called crystallized intelligence, which is sort of like wisdom. It's like the buildup of knowledge over a lifetime and having insights. And so crystallized intelligence goes up. Fluid intelligence, kind of speed of processing and coming up with things very quickly, goes down. But you have this increased wisdom and knowledge base that goes up. Also, what's interesting is as you age, just a healthy aging brain, not a neurodegenerative disorder, but we do lose some cortex in our prefrontal cortex as we age, but that actually might open us up to being more creative. It might also open us up to more likely to just say how you feel without a filter too. But we can become more creative as we age because we're less constrained. We're less constrained by the prefrontal cortex, which is telling us not to think outside the box.
Awesome. John asks, what is intuition and where does that exist in the brain, and what does it mean to develop intuition?
I think of intuition as these unconscious insights that pop up. So, as I was saying, if you let's say you're deciding whether to marry somebody, you can consciously make a list of okay, I'm going to write down all the pros and all the cons, and then I'm going to logically make a decision about should I marry them. Well, that might not lead you to your best decision, right? They say, okay, rely on your intuition, rely on your gut feeling. What that really means is you've taken in all the information, you let your unconscious process it, which can do way more complex processing than our limited consciousness. And then what you end up getting is a feeling. they say you feel it in your gut. That's your unconscious having processed something and then giving you it, saying, okay, this is, the answer. But you have to kind of sleep on it. You have to let it go. You have to stop thinking about it. And that's why often people have these insights, like when they're in the shower or when they're going for a walk. It's when you're not thinking about it, but your brain is still working on it. So like, let it go, take in all the knowledge and then let it go, and then rely on what we'll call intuition, which is really, there's no one place in the brain where it is. It's this unconscious processing that eventually bubbles up and sends us a cue.
Great. Awesome. Here's one more question from the Zoom before we'll switch over to our live questions. This is coming from Channelview High School. Does trauma affect your brain even if you're unconscious, and how?
Even if you're unconscious, or can it affect you?
Yeah, maybe how does trauma affect your unconsciousness or your subconscious?
Yeah. Right. Yeah, I mean, trauma can certainly affect us unconsciously. The brain is constantly trying to learn from its environment. And when, let's say there's a negative association with something happened where, I mean, basic things is, I don't know if you would call this trauma, but early behavioral studies trained this little boy to be afraid of this white rat, and then over time, by like playing a really loud, obnoxious noise with it. And then it would associate that with the noise, or I think it was a white rabbit, whichever it was. And then that kid extrapolated and then started becoming afraid of anything that was white and fuzzy, like a Santa Claus mask, or, and it scaled out. So we might get this one negative association that we're not even consciously aware it happened. And then suddenly we have all these fears and we're avoiding things. And that was something that was learned, or we were conditioned outside of awareness. There's research now going on that can try to uncondition you also at the unconscious level to try to help you unlearn those associations. But that's a part of like what is happens with trauma sometimes.
Fascinating. Yeah. Wow. All right. Well, I think it is time for us to jump over to some students who are ready to ask their questions live. Our first school that we'll be visiting is Lowly Marshall's 9th grade honors biology class at New Road School in Santa Monica, California. So I'll let Lowly take it away here.
I think they're on mute. That's their contact.
Yeah, I think she's gonna have to get the students. Oh,
Can you hear me?
I can hear you. Yes.
Do we need the other computer?
Ideally, yes. Just one second.
Yeah, our school's pretty small, honestly.
Thanks for your patience, everyone. Okay, here we go. Okay, it looks like you're muted. I do see you.
There. Yay.
If you could mute the other screen. Thank you.
I don't hear her.
Okay.
Great.
Are we there?
We're there. Welcome.
Oh, you left.
No, you can't hear.
We know.
Oh no.
We can see you. Can you see
Sarah,
us?
can you hear me?
Yeah, I can hear you.
Yeah.
And see you.
Okay,
Yeah.
so they can hear me.
Great.
Hi. Okay. So great. My first student is actually Charlie, and she has a question. And this is Charlie.
Hi. I okay. I wanted to know what happens to like a person's consciousness and brain after a hemispherectomy.
That's a good question. So that's basically when a hemispherectomy is when you remove one hemisphere of the brain, right? And it depends on the age of the person. So if you do it when they're very young, you actually don't see significant differences. It's amazing. You can have just half a brain, and it takes an expert to really be able to figure out that they're missing half their brain, because you adapt and evolve. There's some things to do with coordination and controlling one side of the body or the other, but that one hemisphere can take over a lot of functions. If you do that in an adult brain, you'll see drastic problems, right? Because they've already now relegated, like, okay, this part of the cortex controls this part of the body, and this is relegated to that, right? That clay has been kind of molded and formed and specialized. So now you'll see significant deficits. But there are these really interesting studies where they cut the corpus callosum, the connection between the two hemispheres. And again, you don't see that much difference, but there are certain things that you do start to see when people, the two hemispheres are not communicating. But so the answer is, like, it won't have that much of an effect if you do it to a baby whose brain is still developing, because that other hemisphere can take over. But to an adult, you'd have severe deficits, especially if you took out the left hemisphere where language is lateralized mostly too. Then you wouldn't be able to speak. It would be a significant life change.
Question.
Thank you.
Okay, and then my second student is Vigo.
All right, let's go with the
Hello.
Hi.
I really wanted to know, so you were talking about how if you do something long enough, you unconsciously start doing it. So when someone is sleepwalking, is that just like unconsciously walking, or is it something completely different?
So normally when we sleep, there's part of our brain that kind of paralyzes our body, so we don't act out our dreams, we don't move around. But when people who sleepwalk, is actually an abnormal brain activation where it's almost like part of the brain is awake and another is still asleep. And so a person will just start acting out things. Like, we can do basically a lot of things without consciousness. That's what sleepwalking tells us. You can get up, you can walk around, you can make food. You might not make the best food because there's not a lot of conscious control there, but you can do basic things with your body, can do it instinctively without having to think about it. And we see that when there's this dissociation in sleepwalking between consciousness and sort of awakeness, right? Because there's being awake and then there's being aware. So when you can be awake and doing things and not be aware, you can be aware, like when you're dreaming, right? And you remember the dream, but you're not awake. So we can divide out those two things, but basically it's the brain is not functioning the way it should be, and you're getting one part of it waking up and the other still asleep, and then you can act out all of these things without being aware of it. Thanks for the question.
Thank you.
All right, well, thank you very much. Very appreciative.
All right. Thank you to Lily Marshall's class and Charlie and Vigo for asking those phenomenal questions. Fantastic. And we've got another class who's going to be joining us. This is Nancy McCall's 9th and 10th grade biology class will be our next questions. We'll bring them up. In the meantime, Heather, I've got another question from the crowd. Is there any research into how much relative wealth in childhood positively or negatively relates to creativity? Other than the trauma of hunger and malnourishment, does the experience of poverty and insecurity have a predictable impact on creativity?
It's a really, really good question. Very interesting. I don't know about the research in that area. But I do know that if you have, life stressors, if your basic needs aren't being met, it can be hard. Your attention is focused on that. Or if you're hungry, it's hard to think, right? It's hard to be able to get to these sort of these higher level brain states if you don't have enough glucose, right? And because it does take energy. So I would imagine that it would have an effect. I just don't know the research or exactly what that effect would be and how, but that's really interesting. I'm going to look into that.
Yeah, super fascinating question. Okay, looks like we are being joined by Nancy McCall's class. Hello.
Hi. My question is, my name is Mason.
Hi,
Hi.
Mason.
Do combat sports affect creativity in the brain?
Combat sports, like what kind of sports are you talking about?
Like boxing, mixed martial arts, stuff like that.
Well, I mean, there's a couple of things with like contact sports. Like if you're getting hits to the head over time, it could have a negative impact. We see that, whereas basically you have the brain, that's this soft piece of tissue, and then the skull, which has actually these hard ridges in it underneath it. And if the brain shakes inside the skull, you can get these tiny little micro tears in it. And you don't really see them in a scanner, in an MRI, but over time, you keep shaking your head inside the brain and getting these little micro tears in the white matter, which is the connectivity. You can start to see effects. Problems with impulse control, emotional regulation, issues with personality. It usually affects the prefrontal cortex. So my caveat with the contact sports is that you have to really be careful of getting blows to the head, getting hit in the head. Think of it like a car accident. You get a car accident, you get whiplash, and the brain shakes inside the head. There can be some side effects to that. So I wouldn't say it increases creativity. That being said, if you take away this idea of getting blows to the head, sports in general are really good. Physical activity is really good for the brain. It increases blood flow, and people who engage in sports, I would imagine, are going to be more likely to come up with interesting ideas because they're active. Physical activity really helps the brain. So I think there are positive aspects to sports, but I'd be really careful with the sports where you get your brain being shaken and head injuries, because that can have a negative impact over the course of a lifetime. It might not be just one blow, but blow after blow after blow. After a while, it does build up.
My other question is that what can I do to be a more creative student?
So the best thing you can do is learn as much as you can, right? The basic facts of everything. And then if you want to be creative, don't try to be creative. Don't think about it. Go for a walk, do something else, take a shower, and then your brain will keep working on it. And that's when the insights come. I would say to be a good student is learn the facts, which can sometimes be boring. You're just memorizing things, you're learning things, but then it's like you're storing that information, you're putting it into the file cabinets in your brain, and then you let go. Don't try to be creative. And then suddenly you'll be like, wow, this idea just flashed up. I realized, oh, this goes together with that in this interesting, unique way. But the best thing you can do to be creative is to let go, is to not try to be creative, but fill your brain with information so it has stuff to work on. And then it can have better chance of making a novel association between ideas.
Yeah, thank you.
No problem. Thanks for your question.
Awesome. Thank you so much, Mason. And thank you so much to Nancy McCall's class. And I think, unfortunately, we are running out of time for questions, but those were all phenomenal questions to everyone. And thank you so much to everyone who's been dropping their questions in the chat. Heather, I do have one more question for you before we sign off. How can students get in touch with you if they want to learn more about what you're researching or ask further questions?
Well, I have a website, heatherberlin.com, that you can go to, and you can contact me through that. You can also follow me on Instagram and Twitter. I'm at Heather_Berlin, and I usually will post some interesting articles, things that talks I'm giving, and we can interact on Twitter, on Instagram. I'm pretty active on that. So those are some of the ways that you can get in touch, ask a question. I'm always happy to, answer. I love to hear what people are thinking about the brain, because I'm so thinking about it all the time. I think everything is fascinating about the brain, but it's really nice to get the feedback to like, what are you interested in? What are your questions? And if I can answer them, I will do so. I can't answer everything, but we still don't know everything. We don't know how deja vu works, for example. So there's a lot we don't know, but there's certainly a lot we do know, and I'm happy to share that too.
Awesome. Well, thank you so much for taking the time to join us today. I think everyone really loved it, and I definitely learned a lot myself. I might go take a nap after this Zoom.
Yes, let's all take a nap. It's good for creativity.
I love it. I love it.
Excuse now. Tell your parents. I have to take a nap. Dr. Berlin told me to. Sorry.
Awesome. Well, thank you so much to everyone for joining us. And thank you so much to all the students and teachers who participated in this virtual field trip, especially the ones who volunteered to go live on camera. That can be nerve-wracking. So we really appreciate it. Your guys' questions were amazing. We also really value your feedback. So if you loved this virtual field trip, we'd love to hear it. If you didn't love it, we'd love to hear it as well. So please, if you could fill out the survey at the end of this webinar, you'll see a link. If you could click on that, that'd be great. If you're watching on YouTube or Facebook, there will be a link to that survey in the chat. So if you could fill that out, we really, really do appreciate it. And of course, we couldn't do field trips like this without our funders. The funding for Your Brain is provided by the Alfred P. Sloan Foundation, the Nova Science Trust, the Corporation for Public Broadcasting, and PBS Viewers. Additional funding is provided by the George D. Smith Fund, Incorporated. If you're interested in seeing Heather and Your Brain, you can watch both episodes, Perception, Deception, and Who's in Control, on Nova's website, our YouTube page, or on the PBS app today. You can also follow Nova Education for more educational content and events and opportunities such as this one by following us on our Facebook, Twitter, and we will be publishing our PBS Learning Media Collection for Your Brain this fall, which is really exciting. And we will be posting more about that on those channels. So please do follow if you're interested in creating some lessons around your brain content that we learned about today. All right. Well, I think that is all for now. Thank you again to everyone. Thank you so much, Heather. This was really illuminating and fascinating. And I think with that, I'll say goodbye. But until next time, we'll be back with more virtual field trips very soon.
Thanks, everyone.